Okay guys, this is part 6 of the MATLAB. So we are continuing for the matrix and its operation, and then we're going to move from the rank of the matrix to the determinant and so on. So let me see what we have. So okay, and we were here, that's right. Yep. Yeah. So in the previous class, in part 5 that you can find on the YouTube, we were talking about the rank of the matrix, and rank of the matrix reveals linearly dependent or linearly independent of columns or rows of a given matrix, right? So, and I told you that the matrix is we name it as the full rank if all the columns or rows of that matrix are linearly independent. Okay, so but before going and viewing that, I'll then go to the determinant. So I want to teach you another command in the matrix and vector. So I talked about the zeros that gives you this, right? You have one row of the zero and 3 columns, that's right? Or if you remember, I told you about the zeros and 3 and 3, that gives you a matrix that has 3 rows and 3 vectors of the zeros. And also I talked to you about remember I4 gives you a unity matrix or identity matrix, and then I say I don't know, 4 and 5. This is very bizarre what we have in the matrix. So this kind of things. Another command that I want that you know is ones. As its name implies, it gives you ones in, for example, here 1 row and 3 columns. As you can see, it can be written as this. Okay, let me see if it is recording this. Okay, so you can make it as a matrix at the same time. So you can say it is can be 3 and 3, right? This is a matrix of all things are 1. So you can use this in the manipulation of the matrices. Suppose that you have this matrix 1 1 1 1 1 1, that's right, and minus 100, 0.5 and 6. This is the matrix that we have, 3 by 3. So but you can use this here. You can say ones. How many rows we have? We have 2 rows of 1 and 3 columns. So ones, 2 and 3, and the result is again what? The same as before. This is this matrix. Here we go. This matrix is equal to this matrix. That's right. So these are the things that is good to know. So we have these kind of commands. Now about the matrix determinant. So let me teach you in the notes first, okay? From a basic algebra that I'm pretty sure you have seen in your high school. So if you have a matrix, say 2 by 2 matrix, guys, here we go. So you have a matrix A is, say, A, B, and C, and D. The magic happened because suddenly color changed by itself. So determinant of this matrix is gonna be how much? AD minus BC, that's right. Example of that, if A is 1, 2, minus 4, and 5, so the determinant of this matrix is gonna be 5 minus 8, gonna be 13. Okay, so and now if we have a matrix of 3 by 3, say is A, B, C, D, E, F, I, J, and K. So determinant of this matrix, for God's sake, is going to be 1 minus I plus J, that we named this as, you remember, cofactor. Remember, in A, so I'm eliminating this column and this row, so determinant of this E, F, J, and the K. That's right. So again, plus minus I cofactor. That's right. In B, eliminating this and this. So the rest is gonna be D, F, I, K. That's right. Plus cofactor I plus J in C. So determinant of this part, D, E, I, D, I, J. That's right. So example of that. So let me go to the example. So the example gonna be example gonna be this matrix. So matrix 1, 2, 3, 1, minus 2, 3, and 3, 1, 2. So based on the calculation, determinant of this gonna be, so cofactor of this minus 1 to power of I and J. I and J of this I 1 plus J. First row, first column. It is 1 and minus 2, 3, 1, 2, right? Plus cofactor of this is first row, second column, 1 plus 2 in 2. That's right. And now 1, 3, 3, 2, right? Plus cofactor of these elements. One row, third element, third column. So, and 3, 1, minus 2, 3, and 1. So the result gonna be, so this is gonna be minus 1 to power of 2, gonna be 1. So it is minus 4, minus 3, determinant of this. And now minus 1 to power of 3 is minus 1, minus, oh, okay. So, and you have a 2 here, it's gonna be 2 minus 9. Plus, minus 1 to power of 4 is 1, 3, 1, minus and minus, plus, plus 6. So what you're gonna get is minus 7 plus 14, which is minus 7 in minus 2 plus 14, plus 7, 21. Right? And this is 7, so it's gonna be 28, as you can see. Okay, so let us do this in Matlab. That's right. So if we go to Matlab, let me make sure it's recording. Yes. So we're gonna have. Let me take this down. We have it. So we're gonna have A is equal to 1, 2, 3. That's right. 1 minus 2, 3. That's right. And 3, 1, 2. Okay. So the command in Matlab is det, because it's determinant. So determinant of the A gives you the answer, which is 28. So, but if we have higher orders matrices, like as 5 by 5, 10 by 10 for the rescue robot I have in the lab, so it's 18 degree of freedom. So we're gonna have 36 by 36 matrix. So if you want to calculate its determinant, so good luck. Okay. So that's why it's very powerful, like this matrix. So say, let me, A is this. I'm gonna add 2 more things, 100, 100, and 1. That's 5 by 5. Minus 1, 4, 1, 1. And now it is 1, 2, 3, 4. So 0, 1, and 0, 1, and 2. That's right. And the last row gonna be 3, 5, 2, 100, 2. So this is 5 by 5 matrix. So it's enough that you say determinant of the A, bingo, comes up. That's right. So now guys, now I want to connect what I'm teaching in this class and the part 5. Look at here guys. So guys, look at this matrix. Look at this matrix. Oh, here we go. Look at this. This matrix is 1, 2, 10, 2, 4, minus 5, and 4, 8, minus 3. So if you ask me what's the determinant of this matrix, without solving, only by looking at, I'm going to say it is 0. Why? Because there's a relation between a matrix determinant, a relation between matrix determinant and rank of, that I taught you in chapter 5, in the part 5, rank of a matrix. That's right. So look at here, I'm talking about this column. If I write based on whatever I taught in part 5 that you have in the YouTube, you're gonna have 1, 2, 4 plus R2, which is 2, 4, 8 plus R3, which is 10 minus 5, and minus 3 is 0. That's right. So it's enough that I select R3 is 0 to satisfy this relation, and I'm saying R1 is minus 2 and the R2 is 1. If you put there, you're gonna see that this equation is satisfied. So based on whatever I taught you about the rank of the matrix, or linearly dependent or independent columns or rows, you see that because 2 of these coefficients are not 0, so this is linearly dependent, so the rank of the matrix is not full rank. That's right. So if the rank of all the matrix was full rank, so we had rank of this A had to be 3, but because you have at least 2 of the columns, okay, 2 of the columns that are linearly dependent, so you have to say 3 minus, because you have 1 is 2. That's right. Understand? So if we implement this in Matlab, I have a point for you guys. Hold on, about determinant. So if I say, let me clean this. Oh, this is the command that I'm cleaning the screen. CLC means clear. CLC. Okay. So A is 1, 2, 10. Okay. 2, 4, minus 5. 4, 8, minus 3. That's right. So if I say rank of this matrix, obviously gonna be 2. Okay, because this column is double of this column, so it's linearly dependent, so matrix is not full rank. When matrix is a full rank, that the rank order is equal to the size of matrix. Okay, so and obviously I'm talking about a square matrix, because when you go to courses like ME 696 linear system theory, maybe you're gonna see non-square matrices, and you have lots of things that about the rank of the matrix. So now, and obviously if your matrix is not full rank, its determinant 100% is 0. No doubt, guys, no doubt. Okay, understand? So if you see that a column or rows of any matrix are linearly dependent to other ones, so the determinant of that matrix is 0. Now look at the other example I want to give you here. Okay, let me go to a little higher order, right? So is recording? Yeah. So suppose this matrix, guys, A is a little large. 2, 3, 4, 5, minus 100, minus 200, minus 300, 4, 4, 2, 1, 0, 0, 0, 0, 0. If you want to ask me what is the determinant of this matrix, I'm going to tell you 100% 0. This is not magic, because if you look at the rows of this matrix, guys, the rows of this matrix, okay, and okay. If I write based on the equation I taught in part 5 that you can find on YouTube, you can write R1 0 0 0 0 plus R2 4 2 1 0 plus R3 minus 100 minus 200 minus 300 and 4 plus R4, which is 2, 3 and the 4 and 5. It is 0. That's right. To satisfy this, the immediate solution that I can choose is that I can say R1 can be any non-zero number, because any non-zero number by this can be 0, right? I don't care that R2, R3 and R4 what are the numbers, 0 or non-zero, but based on definition you can see that these matrix rows are linearly dependent. So the rank of the matrix maximum gonna be here 3, because one of them is done. That's right, it is 4 by 4 matrix. So because your system is not full rank, so its determinant gonna be 0. Let us do that together. That's right. Here we are. Okay, so look at here, CLC. So A is 2, 3, 4, 5, minus 100, minus 200, minus 300 and 4. Okay, and 4, 2, 1, 0. And the last line is 0, 0, 0, 0. Okay, here we go. That matrix. So if I say rank of the matrix, here is 3. So it's not full rank, because matrix is 4 by 4. If your matrix is full rank, the rank must be 4. Okay, so its determinant 100% gonna be 0. There's no doubt. Now look at here. If I say this matrix is 1, 3, 4, 5, 6, 10 minus 10. Okay, how many? 1, 2, 3, 4, 5, 6, 7. 1, 1, 1, 1, 4, 4, 2. And the zeros 1 and 7. Okay, and ones 1 and 7. Okay, 1, 2, 3, 4. Now ones 1 and 3, and zeros 1 and 4. Okay, and zeros 1 and 4, and ones 1 and 3. Okay, so it's gonna be 1, 2, 3, 4, 5, 6, and minus 100, 100, 2, 2, 1, 1, 2, 4, and 9. So this is the matrix that zeros, ones, 3, 4, 5, 6, 7. This is 7, 7, 0, 7, 4, 5, 6. So we have one number here. 9. Okay, this is the matrices, right? Well, looking at this matrix now, I'm going to ask you, this is 7 by 7 matrices, right? What's the rank of the matrix? What's the rank of this matrix? I'll give you 1 minute. Don't go forward, because we are learning. Rank of this matrix is, At least a maximum is 6. Because of these ones? No. Because of these zeros. That's right. Because making the rows of this matrix linearly dependent. So the rank of this matrix maximum gonna be 6, not 7. So it is not full rank. So determinant gonna be how much? Obviously 0. You got the point? Okay. Now you know what's the rank and its relation with the determinant. Now it's recording. Okay. Now let's go to inverse of a matrix. Okay, inverse. Guys, this is a very important topic because inverse of a matrix is a very important topic in the ME 596 that I and my colleague Dr. Nelly we are teaching hopefully in the San Diego State. I have been teaching for a long time, okay? And you will see on that course. So suppose that you have a 2 by 2 matrix. A, B, C, D. From the algebra, you know that the inverse of a matrix is gonna be ADG, means adjugate divided by determinant of the A. For a 2 by 2 matrix, adjugate of that, you are switching the place of this and this, dA, and making the non-diagonal elements as negative. Determinant I taught you in this class, it is AD minus BC. Right? For example, you have 1, 2, and 3, and 4. So determinant of this matrix is gonna be adjugate of the A, so gonna be 4 minus 2 minus 3 and 1. I'm switching the diagonal and changing the sign of the non-diagonal, and it's determinant 4 minus how much? 6. So it's gonna be how much? Minus 2, right? So it's gonna be 4 divided by minus 2 is minus 2. Minus 2 divided by minus 2 is 1. It is minus 3 by 2 plus 3 by 2, which is 1.5, and minus 0.5. So, but you can avoid that, specifically when you're dealing with the high order matrices. How? I'm doing here. Clear? So the matrix A is 1, 2, that's right, 3, and 4. You got it? This is the matrix. So if I say in, means inverse, inv, IMV, here we go. As we did, it is minus 2, 1, 1.5, and minus 0.5. So it's very easy. That's why Matlab is very, very important and powerful, these things. Okay? Understood, guys? So now it's recording. Now let me go to alternates. So we need the matrix determinant, and we judged about that. There's a mathematical relationship. Let me make it smaller. Relationship between rank and determinant of a matrix given. How? It's good to know that if a matrix is not full rank, its determinant is 0. Okay, and you can see in this matrix the second column is double of the first column, so they are linearly dependent. Rank of the matrix is 2 and the determinant is 0. Okay, now please do this at home as example, as the homework for the determinant of a matrix. Please do this at home. Okay, now matrix inverse. After knowing about the matrix determinant and rank, we are now ready to calculate the inverse. The inverse of a matrix is very important in many courses and research topics. Okay, as we did here. So add is means adjugate. So and this is in of A. Understand? So let us do this together. Okay. as a practice, guys. So clear. A is 1, 0, minus 4, and 6. So if I say inv of A, you're gonna have this number. So the B is 1, 3.4, and 2, 3 by 3. 1, 6.45, and 1, and 0, 0, and 1. That's right. Continue. No. Oh, there is an extra bracket here, guys. So inv of B gonna be this number. This is super fast. That's right. So guys, and I have 2 points. So you can do the C at home. Okay, do the C at home. I want to go to the D, guys. Matrix D is 1, 3, 2, minus 4, 4, 5, 0, 0, 0. So what do you expect to see as inverse of this matrix, guys? I'll give you 1 minute to think about that. Please don't move the video, because we are learning, okay? Don't go forward. Let us see. Gotta be this. That's right. Huh? It's gonna be this. So why? Because I told you determinant of the, it's okay, let me talk about this. Determinant of the D is how much? 0. Guys, how is possible that the D has an inverse, guys? Okay, see, if D is this, so inverse of D gonna be infinity, guys. Understand? Because look at here, guys. Look at here. Because here is determinant is 0. Okay, so any matrix divided by 0 is infinity. So we don't have inverse of this matrix. I have an important message for you guys, because as I taught you, the last row of this matrix is 0. It means that this is not full rank matrix. It's not full rank matrix means that its determinant is 0. Its determinant is 0 means it goes to the denominator, so the inverse is gonna be undefined. Understand? So we say in the robotic science, in some cases we say that your robot is in a singular position. Singularity is one of the reasons is that you cannot have inverse of that matrix. Okay, we're gonna go this in the robotic science. So now let us do this. E is 1, 2, 3, 4, 0. Let me do this. 0, 1, minus 2, minus 3, 4, 2, 0, 0, 2. This is the matrix. If I say inverse of E means inverse of this matrix, what do you expect to see? Oh yes, an error message. It says matrix must be squared. This is non-square matrix, and you're gonna see this kind of the matrices many times in the robotic course, guys. Many times. Okay, so how we overcome this problem, I'm gonna teach you the next class. Okay, guys.